Hello, I am Hasan from Opta Center for AI at Curtin University, presenting our paper that address WASSA 2023 Empathy, Emotion, and Personality Shared Task. If I start with the task at first, in this task, the dataset involves two primary information. One is essay, another is conversation. In this dataset, participants first read newspaper articles that involves harm to an individual or entity. Based on the articles, they write an essay about it. Following that, they also had a conversation between two participants. In addition to this essay and conversation, there are also other demographic and other personality information in this dataset. With all those information, there were several prediction challenges. We participated all for regression tasks. For example, from conversation, we predicted emotional polarity, emotion, and empathy. From essay, we predicted empathy and distress, also big five personality, and also interpersonal reactivity index. To address this challenge, our overall system includes multiple transformers. First, from those numerical information available in the dataset, we converted into text domain. Following that, we used a pre-trained T5-based summarizer to summarize lengthy article text. Then we also used another pre-trained T5-based model to paraphrase as a data augmentation tool. Finally, we fine-tuned a pre-trained BART, and of course, the final output of this model is a scalar value that involves predicting empathy or distress or openness or fantasy or any other quantity. In the conversation level task, the demographic information were unavailable. So our conversation level model involves only the paraphrasing to augment the training dataset and also the summarized articles. And of course, the system implementation is publicly available in our GitHub repository, which can also be accessible through this QR code. So our first subsystem, which is number to text mapping. So as I said, the dataset involves several numerical features, for example, gender, age, or education level. First, we converted those numerical information to text in using this template. For example, if a participant's age is 30, we convert it to my age is 30 years. Then article summarization. So the newspaper article text, as we normally know, that article normally have longer sequences. In this data set, the article had a maximum of 20,047 characters. If we compare the combined demographic and essay in text, which had a maximum of 956 characters, which resulted in 236 tokens. Now, BART can allow only 512 tokens at maximum. So of course, we can see 20,047 character will result definitely more than 512 token. So we cannot accommodate all those characters. So we employed a pre-trained T5 based model to summarize those lengthy article. The resulted article had 987 character at max. So of course, we can see it will be reasonable to consider within the BART tokenizer's limit. And in the data set, the number of samples in essay level task was roughly 1000, and in conversation level task, there were more than 10,000 data samples. Yet we utilized a ChatGPT paraphraser on T5 base, which is basically a pre-trained T5 based transformer using ChatGPT paraphraser dataset, which was accessed through Hugging Face. So we utilized this to paraphrase the demographic, essay, and article text, which effectively helped us to double the size of the dataset. Now, in our model development, we tune these hyperparameters. we experimented with 3 different model architecture: BERT-based, Distil-BERT-based, and also ALBERT-based. In case of conversation level dataset, we experimented with a comparatively larger batch size because the conversation had a smaller number of characters as compared to the essay. And we used Optuna hyperparameter tuning framework with its default sampler and pruner to tune the hyperparameter setups. These are the resources that we used. We greatly acknowledge NCI Australia for the cloud GPU support and also the cloud machine support. We primarily use Tesla V132GB GPU, and these are the Python packages with corresponding versions. Now, if we discuss about the results, so first of all, here we can see the inclusion of summarized article does improve the performance from 0.819 to 0.865, which is a Pearson correlation coefficient, the official evaluation metric of WASSA 2023 shared task. So as we can see that definitely converting those longer sequences to smaller sequences helped us improve the performance. And this particular result is basically a 5-fold cross-validated performance from essay level empathy prediction challenge using a Distil-BERT model. Now, our optimal hyperparameters that was developed by the Optuna hyperparameter tuning framework. So for all those different tasks, these are different learning rate, batch size, and seed that has been detected by the Optuna hyperparameter tuning framework. And these are the corresponding Pearson correlation coefficient on the development set. Now, we also investigated with hyperparameter importances. This particular figure shows that in essay level empathy prediction task, learning rate was the most important, which has a 56% relative importance compared to batch size and seed. Whereas in conscientiousness prediction, all 3 hyperparameters are equally important, and it varies across different prediction tasks. For example, in personality distress prediction, we can see that learning rate was the most important one. So this task-specific nature of fine-tuning pre-trained transformer models guided us to train separate models for separate tasks, because as we can see that their performance is quite heavily dependent on different hyperparameters. That's why we train different hyperparameter enabled model in different tasks. And this is our final test set performance. Our model achieved its highest performance of 0.750 Pearson correlation coefficient, which was achieved from conversation level empathy prediction. And for other cases, we also achieved competitive performances. Now, if I summarize, the whole task was actually prediction of empathy, emotion, and other personality traits from essay and conversation. To address this challenge, first we converted number to text. So the numerical information, for example, age, sex, race, education, income, we converted those information to text. Followed by that, we summarized the lengthy article using a pre-trained T5-based transformer. Then we also used another pre-trained T5-based transformer as a data augmentation tool by paraphrasing the demographic information, the essay information, and the article information. We tuned the hyperparameters using Optuna hyperparameter tuning framework. Then we fine-tuned a pre-trained BERT model for our final prediction, which resulted our system's best performance as a 0.750 Pearson correlation coefficient. Thank you for your time. That's all I wanted to talk today.